Okay, so we're going to load test a 3/8 inch. Okay, all thread, all thread. It's 3/8 inch, 16 thread, and this is just a overrated, overpriced tensioner, and it translates to the hydraulic force, PSI, and this will be foot-pounds of pressure it takes. So, or force it takes rather. And there we go. See the inside gauge? Alright, so this is epoxied in. Remember I did the epoxy in the previous video. Epoxied in this about 2.5 inches. Now let's go ahead and check it out. We'll just watch. It's going to make a little noise while the plates I use just some brakes, get some elevation. So, we're going to see how this epoxy performs. And all we got to do is watch the gauge. And if I let go and it creeps down, I know I'm losing it. Alright, right about now it's starting to feel tension. 1,000 psi. Let's keep going. I let go of the gauge and it's still stable. So let's go to 1,200. Still stable. Alright, we'll wait a sec. Won't wait a moment. Watch it at 1,200. I found it's best to just let it relax and see what you really have. I'll put a wrench on it now. So let's just watch the gauge. You can watch the whole tool if you want to get fancy that way. We're at 14. Okay, this is epoxy. And we're at 1,600 pounds of force with 2.5 inches. And this is pretty taut. I'm pulling on it. If I pull on it, you can see the needle move a bit. So I can probably go a little bit better than that. Let's go to right about there. And let's just let it relax. Now I'm going to grab it and pull on it a bit. Let's see if I can get the gauge to move. I sure can. So it's still got a little more love in it. Okay. So we're at 1,800 pounds. And we're only at 2.5 inches of epoxy. And we'll just let it sit there for a moment. The quickest thing you don't want to do is what Rush did, for example. Quickly race it up to get a higher number. No, remember Rush from Titan? And I said how you have to wait and let it relax, see if it can return. There's 1,800. All right? It's holding at 1,800 pounds. Let's take it back down now. Now let's cycle it back up. Let's go to 1,800, nice and smooth. Okay, there we are at 18 again. Maybe I'll give a crumb over it. Okay. Now we're over 1,800. And we can just let it sit there. If it's not, it's right now it's having 1,800 pounds of force pulling on it. We don't know, I don't know if it's failing right now because it hasn't been time tested. It's only been tested to this load here, and I've quickly dialed it down. Told you, I could take 1,800 pounds. It would be deceptive of me because this has not been time tested. So I'm going to pause the video and come back to you and set my timer. I'm going to come back in about 5 minutes just to see if it's doing any settling. So it can relax a bit. So we're at 18, so it can relax, you know. The steel can relax, it's being stretched. Maybe the steel's being stretched. Maybe the epoxy's being pulled on in the concrete. It can relax a bit. But if it just drops, you know, significantly, I don't like that. I don't want that. So 1,800 pounds. Let me pause it and I'll be right back. Okay, so waited maybe 15 minutes now and it only dropped a little bit. Let's go ahead and, that just could be relaxation. Let's go ahead and take it up. We're at almost 2,000. There's 2,000 right there. And let's let that relax. I'm going to pause. I like this jump at 2,000, so let's let that relax for a moment. I'll be back to you after I give it a few minutes there at 2K. It's a touch over 2K. Okay, noteworthy. Now when I grab hold of this and yank on it, you notice the gauge is not moving. It's not bouncing. So now we're in my part where it's really does not have any slack in it. There is no slack in it. My bit of pulling does not create an extra force there. So we're at that point. We're at that point where it is totally taut. Okay, these plates, I couldn't pull them out. I would need 2,000 pounds of force or greater to pull that. Oh, that would be equal. I need greater than 2,000 pounds to pull that out. Okay, it's been another 10 minutes or so, and we're still at 1950 about. Let's go ahead and take her up. Let's stop it. I feel a little creak in there. Let's see what we got. Let's go to 22. All right. So I'm still turning this, and I don't see my pressure going up much. Let's do this so you can see it, perhaps. All right. So maybe I got to come a little closer like that. So in the background, I want you to see the gauge and the movement of the handle. I'm turning the handle, and my gauge is not rising. So I'm in the failure state of this connection now. Now I'm just stressing it, and I'm not getting any more value. So it's maxed out at 22. Now let's see if I let it. Let's just let it hold there at 22 for a moment. And I want you to think of the scale like this. Here's the graph. It goes up, and then comes across, and then it'll peak again, and then it's going to drop off. So it comes up, that's our max, and then it's sort of, as you see me turning, it stays right about there, maybe moving, 10 psi, and then it might re-bite with some debris in the hole, if there's debris in the hole, and give me a little peak, and then from that peak it's going to drop off to 0. I'm sorry, it's going to just start climbing down. This doesn't pop. This won't pop, so it's going to start climbing down. So let me pause it and see if we can stay at 22 for about 10 minutes, and I'll get back to you in a minute. No, 10 minutes. Okay, an additional 10 minutes plus have gone by, and we're at, I had the alarm set to 10 minutes, and I waited longer to come out to it. So we're still roughly at 22. Let's take it to failure now. Let's watch it. So it's spinning. I hear some creaking, but I'm not going really up in value. Just a little bit. That's that peak I'm thinking. Remember, I've never done this specific hole before. So this is going to behave exactly like that. So still climbing. Very impressive still. Very impressive. We're at 2600. Not quite at 26. I'm a little bit shy under 26. I know the gauge. I can't get the glare off. Let's see if I can get us to that 26. Okay. We're at the 26, and I'm a touch over, so we'll see how much it relaxes back. Let's see if I can get you squared up a bit. It's a touch over 26, right about there. So there's, see if I can turn it a bit. Once you see the 2000, we're getting that glare now. It's that right angle from the sun. I guess we look like we're going to have to wait again. Oh, no, it's dropping. No, it's just a little bit of relaxation. 26. That's pretty impressive. I'm almost tempted to wait, and I think I will wait. It's at 26. We've only got 2.5 inches with a 1/2 inch hole with epoxy in it, as you saw in the previous video. Yeah, we're going to sit this one out for a moment. So there we are, still pretty close to 26. We've lost a little bit, maybe 20 pounds worth. Let's keep going. We're at 28. Oh, it's feeling very taut. The feedback I'm getting is very taut at 28. So let's see if we can go to 3,000. Very easily, very smooth. And we're crossing 3. We'll go above 3. No, wait a minute. There we go. We're above 3,000 now, and we'll let it rest for about 10 minutes. Just want to see if it drops in right now. Okay, we're already past 10 minutes again, and we did get a drop. Let's go ahead and take it. Let's just take this to failure now. Let's see where we go. Smooth, not stressing it, not shock loading it. We're at 32. Still climbing. Very impressive on this 3/8 inch, 2.5 inch of epoxy. That's all it is, guys. That is all this is. I'm rotating and it's climbing very slowly. Rotating. We're at 34. Let's round over 34 a little bit. Okay, we're above 34. And we're going to watch it again. I'm going to pause. No, that's dropping pretty significant. That might be... Oh, wait a minute. That might be around the failure. Let's go. It's 36. Let's see what it does from 36. How much it drops. Yeah, see how the needle moved pretty fast? So we're stressing it now where it wants to come out the hole, but before the comes out though, she's climbing. It's only like 2.5 inches. I'll show you when we get it out how much was in there. There's 4,000 coming up on 4,000. Well, I'm pretty impressed. That's it. That's definitely the max. 44,000 with 2.5 inches. That is tight. 4,000, 2.5 inches. This is epoxy. This is why I tell everybody, epoxy it in. Forget these shields and all these other fancy stuff, which I'm going to show you how to set one of these in a moment. Forget all that. It's dropping. The epoxy is the way to go. Let's go ahead and take it out. 42. Go away, B. 44. Nope, 42. Only a 3/8 inch. Half-inch hole. 44. Shit. It's the gift that keeps giving there. 44. Okay. 46. Very impressive. Very impressive. I don't know where we're going with this as far as failure. We're going to find out. Oh, just popped. It just popped. So 46, and you saw it dropped 800. So let's go ahead and let's take a look at that so you can see it, and then I'll take it out from, so I've got to dial it down. Let's take a look at the failure, what it looks like. So 46, give me a second, I'll pause this and I'll take this rig apart and let you look at the failure. But it still had 900 on board, PSI on board, as you saw on the failure. Look, guys, the concrete fractured. The concrete failed. There's our epoxy still. This is very impressive. So that was 1/2 inch and about 8 inches across on this concrete here. This is 4,500 PSI, at least concrete. I put this in myself. I took it out of there. So I know this concrete. That's why I chose to use it. Wow. And there's our failure. It's a beautiful looking failure. There's the cone I talk about, but then it fractured off to the sides. It still feels pretty damn strong. Remember, it's 900 pounds. I'm going to pause this and get a pry bar. Okay, so I'll do it live for you in case it breaks apart differently. Let's see what it looks like. Let's see how far the crack went down. Got to get it out. Without breaking that pipe. Okay. All right. So can you see it? Maybe not. Fracture is about as deep as the. Let me get the camera mobile. Hold on. A fracture is about as deep as the anchor. And a shot across on this side. And I'm going to flip it over. We'll look at the other side. So about as deep as the anchor. On this side. This side. It's about 150 pounds, guys. We're trying to manipulate. So, this one's all the way down to here. It's all the way through. Well, need to see what it looks like now. Still got a lot of toughness in this concrete. It's not breaking apart like I wanted to. We're going to do another one of these, and this time we're going to watch it from out here, and we're going to watch it fracture. But let's go ahead and put this rig back together, and we're going to finish it. We're going to let the fracture finish developing fully. So let me just get the camera set for you. Yep, there we are, and then let me pause it. Birds. Okay, so it should theoretically go back to 900. I'm back connected. So there we theoretically go to 900. Okay, here's 600. 400. Okay, let's just take it to failure, and then we'll be able to look at it. It's there. It's pulling out now. It's nothing. It's just pulling out. It's still got 200 pounds though, force. That's not something to be taken lightly to try to pull out. See how it increases? If I was trying, it would need 300 pounds, 200 pounds. It's still got some fight to it. Look at it open up, crack up. And it's bouncing, it's wavering between 200 and 210, 201, 220. When I get below 200, okay, I'm below 200 now. Okay. All right. I think I'm about maxed, almost maxed to what I can pull this out by. All right. Shake it a little bit. Got it. All right. Let's go ahead and dismount it. Give me a second to pause. Oh, I won't pause it. I'll just do it live for you. Dismount this. And let's take a look at it live. Oh, that's that. So, there's the epoxy. The thumb. Oh, look, there's a void. You saw me screw it in the previous video. And that's just a grip force. And it's not much. If you look at the surface, it's all that surface. You can see the concrete where it's touching. And now this. Well, it fractured, and let's get it apart. There we go. So here's my drill. My drilling. Ah, shit. Let's do this one better. Okay. So there's my drilling. And it's only down like 2.5 inches, like I said. And that 2.5 inches, with that stress burst this section of concrete. So think about that also. How one anchor failure can cause a structural failure and something that's, 8 inches wide and still finished off the depth of this. That's the pressure that the cone is creating. So imagine if you said, oh, it can take 2,000 pounds. So you put 2,000 pounds on it. Well, it only takes a little bit more of loading for it to then make this full crack. So this would really matter as far as you thought that you had that this depth would save you. It did not. That pressure, that cone developed that caused that fracture to be so clean right across the top, as you see there. And it's a pressure cone built up of 2,000 pounds. Look at the air entrainment. See the air voids? The pressure cone built up in here, created that first fracture you saw. But as we finished it off, you saw it was fully developed all the way through. The fracture was developed all the way through. Beautiful, beautiful break. And it's a reverse wedge, if you will. The wedge is inside, the pressure is built up, and fracture. So just think of that when you think about loading that you're loading in the concrete, and you're like, oh, I'm good. Well, think about how it's structurally. It's not just your what you're trying to hold, but you're structurally creating a stress inside the concrete that can cause a failure in the concrete also, not just your anchor. But that's epoxy for you. So with that said, sometimes you might want something sacrificial that will fall out, as opposed to epoxy is going to make it so your concrete fails. But you would never use epoxy to the max. You would distribute that load. Make sure your loads are never there. The loads are never there. Now, if there was more concrete over here, would that help it? You know, you're still going to get the crack. The fracture is going to happen. You're going to get a bursting effect. Sometimes as big as like this, a cone look like this. And I'll show you that in more videos. But now I'm just showing you this behavior with this dimensional material, concrete, that PSI, how this bursted away. That's amazing. It's beautiful. So I said it was about 2.5 inches. It's 2 3/4 to the top. And we can look at it again. Yeah, I'd go with, let's start with the 6. Yeah, I'd go with 2 5/8. 2 5/8. I'd say 2.5. Off by 1/8 of an inch. 2 5/8. So, hopefully you can learn something from this. And again, this is a 3/8 inch, 16 thread, and the failure is in the concrete. The rod has a little deflection in it because I wasn't squared on it, but that doesn't change too much. It was bent slightly. It doesn't change too much. It does create a, well, that's something too you can consider. It does create a higher force value because it's like a torque action. So I might have to give it a little more, a little less value because of the angle, which matters. But we have no epoxy failure. Look at that, no epoxy failure. This is a concrete failure, interface with the concrete. If I'd have ballooned that concrete out even more, it still would have failed. We've got a most smooth hole here, and it still failed. So our measurements are 9 inches, so much for 8. And it took out 5 1/4 inch, 5 1/4 inch section of concrete. Nine inches. And below that, yeah, there's the balance. On each side we have, let's just do it this way. Let's use this one. So it's a bit on of an angle, so that angle is okay, a slight bit of an angle. We're at, so it's 9, 4.5 would be our center line, and we're about 4.5. We're close. See 4.5 where the magic marker is in the middle? We're about there. So it burst that. It's beautiful. Maybe you can see the cone shape this way. See how the cone came up and fractured out to that, out there, the forces. More so that that one. And it's a path, all right? It's a concrete path. It's not, you know, it's however this path was developed because of the structure of the matrix that you're looking at. All right, take care. Love you guys. Thanks for the support of the kitties and love and all that stuff. And I'm going to show you in the next video how to set one of these real fast and simple. We're going to test this epoxy one versus non-epoxied. This is, I'm trying to grab something. Non-epoxy, so that one's epoxied in, and this anchor is not. This anchor can slide right out. Whoops. Come here. So we'll test this one compared to with your leg with a shield. We'll test this one versus this epoxy one, and we're going to see the difference. This is close to the edge, but maybe we'll get lucky and won't fracture. But that's something else you'll take on data-wise. All right, end of this video, and this with another load test done with using the Very 5000. If you guys ever want to look it up, you ever want to rent one, you can rent one. But you have to understand that, you know, what you're really dealing with. Don't max it out. Use, you know, one quarter of it, 1/4 of your values if you can. That way you have plenty of margin. Think about the extra stresses that may be added on it, onto the, like if that was a ceiling and you anchored that to the ceiling, that the above the ceiling is someone walking on it, or loads on top of it. So you've got to consider that those loads are additional stresses to the concrete. So all that must be considered, that it's part of your ultimate load that you need to factor in.